Alrighty, let's do this last side, the second side of this practice, all in one video. So again, we're in our Unit 6 end of unit test practice. I'm on the back side, and these next set of questions, this right here is a great idea of what to put on an index card. Okay, so if you gave an example of each form and what information we are looking for in each form, that tells us different pieces of information. So if I was making an index card helper sheet, would definitely write this example. That standard form gives us the y-intercept, and it's telling us that the y-intercept is this number directly. All right, so this is an example of standard form. We can tell standard form because it has an x squared, or like a 4x squared, or a 6x squared, or something like that. It has an x squared term, an x term, and a constant. Remember that this constant is what tells us the y-intercept. Now, next to it is factored form. Remember, that's something that's got one or two sets of parentheses, and nothing is squared. So factored form looks like this: one or two sets of parentheses, and nothing is squared. So when I look at these examples, this one is standard form. That one isn't. This is standard form. This one is factored form. So I'm even going to get color code here, because I do love doing that. That is something where we have two sets of parentheses, something being multiplied with no exponent, no squared. This one is an example of standard form. Standard form. So standard form tells us the y-intercept. Factored form tells us the x-intercepts. Now remember that these are the ones that we have to change the sign. So we're going to set each factor equal to 0 and solve. Okay. And then our last form that we have, vertex form, tells us the vertex most easily. And we need both the number inside the parentheses and the number outside. So vertex form, it's a giveaway that it's vertex form if we have parentheses and something squared. So each of these is vertex form. So these questions are asking us, for each equation, what type of information does it give us about the graph, depending on the form? And then what is that actual piece of information? So the first one is done for us. It's standard form. I see an x squared with no parentheses. That tells me the y-intercept, and I'm just taking that value, and if it's the y-intercept, that means x is 0, and that number is exactly the y-intercept. Okay. Our second one here, I see a set of parentheses, and I see something squared. That's an example of vertex form, so this is going to tell me the vertex most easily. I'm going to take that number with the x, change the sign to be a -3, that's the x coordinate, and the number outside after tells me the y coordinate directly. I don't have to do anything to it. Okay, so remember that we are only going to change the positive or the negative for the x coordinate only. Okay, this +3 became a -3. All right, our next one is another example of standard form. I see an x squared, no parentheses. That tells me the y-intercept. The y-intercept is just when y is at 2, x is at 0. I see two sets of parentheses being multiplied. Nothing is being squared. This is going to tell me factored form, telling me the x-intercepts. And again, I need to change the sign, the plus or the minus, because both of these are x coordinates. Okay, these are where we're hitting the x-axis. So this x plus 4 becomes one of our intercepts at -4. This x minus 2 becomes a +2, +2, 0. And you may remember we wrote down steps to solve this. We can also put that each factor equal to 0 and solve for x. Minus 4, x equals a negative 4. There it is. X minus 2, the other factor. I wrote 3, sorry about that. We'd have to add 2. X equals a positive 2. There we go. Okay. All right, our next one, parentheses, squared, vertex form. Change the positive or the negative for the x coordinate only. Negative 1 becomes a positive 1. Positive 7 stays the same. There is our vertex. This would also tell me that it's opening downward, so it's a maximum. And last but not least, we have another 2 sets of parentheses, no squared in sight. These are x-intercepts. This one I changed the sign from a minus 1 to a positive 1. And from a positive 5 to a negative 5. Be careful. Please make sure that your x's and y's are in the right spot. Notice that when we have the y-intercept, x is 0. When we have an x-intercept, y is 0. Okay, so if you even need to say that we're going to use the y-intercept, that's when x is 0. X-intercepts are when y is 0. Okay. All right. Our next set just asks us all of the equations of graphs that open up. Circle those. So we're looking for things that open upward or things that are super duper positive. That means we're looking at just what's in front of the x squared or what's in front of the entire equation. This one is a positive, so I'm going to circle it. That one opens upward. This one also has nothing in front of it. That's a positive number going on right there. It's a positive 1. I'm going to circle this. Check out this one. This one's got a negative right there. It tells me to put a box around all equations that open downward. Here is a box around that equation. This one, if we were to multiply these out, we'd have x times x. That's x squared. It would look like this. It's a positive graph. And then our last one is a negative. It's a real downer. In each pair, we want to circle the equation that would have the skinnier graph. It says, remember, the greater the value of a, the skinnier the graph will be. We were talking about things that it makes a steeper slope. So if you have a large a value, its slope is steeper. See how that one's growing a lot more than this one. It has a slope that's not as steep. Okay, so a is a skinnier graph. So out of these two, I'm looking for that multiplier in front of the x squared term that is bigger. This one's bigger. That one's going to be a skinnier graph. This doesn't have a number in front. That just means it's a 1. And 1 is a bigger number than half. Bigger the number, skinnier the graph. Bigger the number, skinnier the graph. 3 is bigger than 2. 2 is bigger than 1. 2 is the skinnier graph. Okay, so it's got a steeper slope or a skinnier graph, a skinnier parabola. Another great thing to put on an index card with a couple examples. Okay. All right, we're cruising on through. Keep up with me. Number 20, consider the function in standard form ax squared plus bx plus c. How can we tell if it opens up or down? Up here, we were looking at whether that a value in front was a positive or a negative. This one opened upward, that's why we circled it. This one opened downward, that's why we put a box around it. So if a is positive, it opens upward. If A is negative, it opens downward. The y-intercept of this equation, let's see, this is in standard form, so I'm going to go back up to something you should have already written on your index card. Standard form gives us the y-intercept. It is whatever the constant is. In this case, the constant is the c value, so the y-intercept is 0, c. Alrighty. We're going to look at each graph and we're going to circle all of the equations that could represent each graph. I see some different things that we're looking at. We're looking at different formats, factored, vertex, and standard. Factored, vertex, and standard. So I'm going to need lots of information for this. Okay. This one has x-intercepts at -1 and 3. Remember that the x-intercepts, x's always change their sign. So this is, we need an x plus 1 as a factor and x minus 3 as a factor. This happened at -1. This one happened at a +3. So I need an x plus 1 and an x minus 3. For vertex form, I got to go find the vertex. This vertex is happening at 1, 4. Oop, that's a -4. It's down below the x-axis. 1, -4. So I definitely need that to be a -4. It looks like this guy here. So B is the one that we're going to circle for that. And remember the x always changes its sign, so that +1 turns to an x minus 1. And standard form, we're looking at the x-intercept at -3. That means I need this -3 here, so that's what tells me it's that equation. Same idea over here. We can go in any order. Doesn't matter. This one I'm going to start from the bottom up. The y-intercept is obviously not at +5. It's not intercepting there. So this one's happening at -5. Even if it falls off the screen, I can see what it looks like. This one has a vertex that is happening here at, let's see, oh, here's 0, 0. So at +3, +4 is the vertex. Now both of these have a +4, so I have to decide which one this is going to be here. And remember the x changes its symbol. And last but not least, my two x-intercepts are happening at 1 and at 5. Both of those are positive numbers, but both of them need to flip their symbol, their sign, so both of them need to be a subtraction. Thanks for checking your answers. Build your best index card. Give yourself examples. Use both sides. Okay? There's lots to remember here about where things are on the graph and where they show up in our 3 different equation types. Thanks, guys. Do your best.